Uh, okay, today we are going to start lesson 3 on unit 5, which is about the slope of the straight line. Actually, before we studied the slope on the previous year, okay, of the straight line, it was the slope of a straight line like AB equals y2 minus y1 over x2 minus x1, okay? It was the change of y coordinates over the change of x. Like if there is a point A, 2 and 4, for example, and a point B, which is 4 and 7. So the slope simply will equal the change on y coordinates. So y coordinates like this one and this one. And of course, this one is for x. So this one is x1, and this one is y1, and this one will be x2, and this one y2. So now the slope will equal 7 minus 4, which is equal 3, over 4 minus 2, which is equal 2. So this is the slope, okay, which we studied before. Now, guys, we are going to study, okay, the positive measure and the negative measure of angle, which is related to the slope, okay? So if there is a straight line like this one, first this one is x and y axis, and this one is y dash and x dash, and there is one straight line like this, okay? So now, guys, there is one angle here, okay, on the positive direction. I mean this one, okay? So actually this one is the positive angle of the slope, and on the other direction it will be this one also with x. I will make it with a different color. From x also to the straight line like this. So this is the negative one, okay? So now, guys, the positive angle, actually it's anti-clockwise direction like this, anti-clockwise. But this one with the same like clockwise direction, okay? So this is the negative, okay? It's a clockwise, and the positive is anti-clockwise, okay? So this angle, actually its name is theta here. Okay, are we clear till now?
Yes.
Okay, great. So the slope of this straight line, okay, equals tangent of theta, okay? Tangent of theta. Okay, guys? So now if there is one example like this, x, y plane, and this one is y dash, and this one is x dash. And if there is a straight line like this, so this one is theta, okay? So simply the slope will equal tangent, which is tan theta. So for example, if it's 45 degrees, so now the slope will equal tan 45, which is equal 1. Okay? Is it clear till now?
Yes.
Okay, great. The next point here, okay, it's the types of angles which we can find here, like the first one. If this one is xy plane, x and y, and x dash and y dash, okay, and the straight line is like this. So now theta, okay, is acute angle. If theta is acute angle, so the slope is positive. Okay, so in case of this angle, okay, is acute, so this means that the slope will be positive. Okay, the second case, x and y and x dash and y dash, and the straight line is like this. So simply, guys, this will be theta, of course. Okay, so now this angle is obtuse angle. So this means the slope will be negative. Okay, are we clear till now?
Yes, we are.
Okay, great. Then the third case, if the angle is like this, this one is x and this one is y, okay, and the straight line is like this, which is actually parallel, okay, parallel to x-axis. So in this case, guys, there is no angle actually from x-axis. So this means this one is 0 angle. Okay, so simply here the slope equals 0. Okay, the
Okay.
last case, if it's right angled like this one is x, this one is y, and this is the straight line, for example L. So now, guys, the angle with x here is right angle, okay, which is 90 degrees, which is, this means also it's parallel to y-axis, okay. So simply this means the slope not defined. Okay, why not defined, guys? Because actually we said that the slope is the change on y over the change of x. Okay, now, okay, actually there is a change on the value of y here, different points on y, right? So each time the value of y change, but x here is the same value. So this means the change of y, okay, over change of x, nothing change on x. So this means over 0. So it's not defined. Okay, guys, are we clear? So now, what is the slope of a straight line which is parallel to x-axis? X-axis, not y. This is y. Parallel to x-axis means that the slope is 0. Parallel to y-axis, okay, means not defined. So if the straight line is parallel to x, or this means, on other words, the slope angle equals 0, okay, so this means the slope is 0. And if the angle is 90 degrees or right angle, okay, or in other words, the straight line parallel to y, so this means that the slope is not defined. Okay, are we clear till now?
Yes.
Okay, great. So now let's solve one example related to this. Find the slope of the straight line which makes a positive angle with the positive direction of x-axis where the measure of the angle is 45 degrees. 45 degrees. This is the positive angle, which is theta. Okay. Okay. It's very simple, guys. We said that the slope equals tangent, okay, of theta. So this means it will equal tan 45 degrees, which is equal, of course, 1. Okay. How to get it using the calculator, guys? Okay. Just I will start the calculator. Then tan 45. Okay. Then equal. Okay. So it will becomes 1 like this. Okay, guys. Is it clear? The next example is to find the slope for this angle 124 degrees and 15 minutes and 12 seconds. Okay, it will be the same exactly because the slope will equal tan theta. Okay, so now it will equal tan for this angle, which is 124 degrees, 15 minutes and 12 seconds. Okay, so using the calculator, it will approximately equal negative 1.4685. Okay, guys, how to get it using the calculator? Tan first, then enter the value of the angle like before. We studied that before on the last unit, okay, in unit 4. Okay, so tan, then the degrees, 124, okay, then this button, which is related to the minutes and seconds, then 15, okay, minutes, then again this button one more time, then the the minutes first, then the seconds, which is 12, okay, then again this button, okay, then equal. So it will give this value. As I told you guys, if the angle is obtuse, so the slope will be negative. So it's 124. Actually, this is obtuse angle. We said that before. Obtuse angle greater than 90 and less than 180. So this is 124. That's why the slope here is negative. Okay, are we clear till now?
Yes, we are.
The next question. Find the measure of the positive angle theta, which the straight line makes with the positive direction of x if the slope of the straight line is. Now, guys, it's a little different, okay? Before in the question, okay, the angle or theta is given, okay, the angle. So before we said that find the slope if the angle is 45, so we said that tan 45 like this. But now, okay, the slope is given. So the first question, slope equals 1.486. Find the angle, okay, which is theta. Okay, actually, guys, here we said that the slope equals tan theta, so this means tan theta equals this value, right? 1.486. Okay, so here, guys, the slope is positive, right? It's a positive value. So this means this theta, okay, is acute angle. Okay. So now how to get theta? Tan theta equals this value, so I will get it using the calculator. Okay, there is one button on the calculator, it's tan, which we always use it to get the tangent of the angle. And also there is one button on the top of this one, which is tan minus 1. We discussed about this one before. Okay, so this means, guys, if the tangent is given, so how to get the angle? Just now theta will equal tan minus 1, this value. Okay, how to get it? Simply, I'm going to press on shift and then tan, then the value of the tangent, okay, which is 1.486. So using the calculator, guys, it then equal, then after you get the value, okay, this button, which is commas like this, to get it in degrees and minutes and seconds. So if you will check now with the calculator, it will becomes like this: 56 degrees, 3 minutes and 41 seconds. Okay, so actually we said that it's acute angle, and now it's acute angle. Okay, let's solve one more example. Find the measure of the angle, okay, if the slope equals -1 over square root of 3. Okay, so now guys, here the slope is negative. So this means theta, okay, obtuse. Okay, let's solve it. Slope equal tan theta. So tan theta equal this value, -1 over square root of 3. So simply theta will equal, again, shift 10, or I mean 10 minus 1 like this, okay, for this value, for -1 over square root of 3. So simply, guys, okay, by using the calculator, we will find that it equals -30 degrees. Okay, but we said in the beginning that the slope is negative, so the angle have to be obtuse. Okay, so now we have to get, okay, the supplementary for this angle. Okay, guys, so this means theta will equal 180, okay, minus 30, which is equal 150 degrees. Okay, are we clear till now?
Yes, sir.
The next question. Find the measure of the positive angle theta, which the straight line L makes with the positive direction of x-axis, if the straight line L passes through the 2 points, -2 and square root of 3, and the second point, 1 and 4 square root of 3. Okay, now there is 2 points are given, okay, which is the straight line passing through them. So now I can get the slope, okay, using these 2 points. Like I said in the beginning of the session, the slope will equal the change on the y coordinates over the change of x coordinates. So simply, guys, the slope now will equal y2 minus y1, so 4 square root of 3 minus square root of 3, which will equal 3 square root of 3. over the change of x, which is 1 minus negative 2. Okay, 1 minus negative 2 means 1 plus 2, which is equal to 3. So now we can simplify these two numbers, okay, 3 and 3, so the slope will equal square root of 3. Okay, now I want to get the angle theta. So this means, guys, tan theta, which is a slope, of course, okay, equals the square root of 3, this one. Now theta will equal 10 minus 1 square root of 3. So simply using the calculator, okay, I can get this one. Actually, it will equal 60 degrees. Okay, so here the slope is positive, square root of 3. So theta is acute. Now we finished. Okay, the next question is the same like this one, and the 2 points are -2 and 3. And the second point is -3 and 4. Now I will get the slope using these 2 points. So y2 minus y1, 4 minus 3, which is equal 1, over x2, which is -3, minus x1. So -3 minus -2. So this means -3 plus 2, so it will be -1. So 1 over -1, it will equal -1. So this means tan theta equal -1. Okay, so the slope here is negative. So the theta or the angle have to be obtuse. Okay, let's continue. So theta will equal tan minus 1 for -1. Actually, if I will get it using the calculator right now, okay, it will equal -45. Okay, this is a negative acute angle. Then I will get the positive obtuse angle. Okay, it will equal 180 minus 45. So it will equal 135 degrees. Okay, guys, are we clear till now?
Yes.
Yes, we are.
Okay, great. Okay. The next point, it's about the relation between the two slopes of two parallel straight lines. Okay. Actually, guys, this one is very simple, so concentrate with me. If this one is x and y, for example, and there is one straight line like this and another one like this, which they are actually parallel. Okay, so for example, this one is L1, line 1 on line 2. Okay, what is that angle here? Theta 1, and this one is theta 2. Okay, so what's the relation between parallelism for the two lines and the slope? Actually, guys, we studied before that if these two straight lines, okay, are parallel and the x-axis will be transversal for these two straight lines, so this means theta 1 equal to theta 2 because they are corresponding angles, right? So simply theta 1 equals theta 2, so slope for the line 1 will equal the slope of the line 2. Okay, great. So this means if there are two parallel straight lines, so their slope will be equal. Okay, if the slope of two straight lines are equal, okay, so this means the two straight lines are parallel. Okay, I mean the point and its converse. If they are parallel, then the slope is equal. If the slope is equal, so they are parallel. Are we clear, guys?
Yes.
Any questions till now?
No, thank you.
Okay, great. So let's solve one example, okay, related to this point. Prove that the straight line which passes through the 2 points 2 and 3, 2 and 3, and negative 1 and 6, negative 1 and 6, okay, it's better to the straight x the positive direction of this is first line, and here, okay, the second line, theta equals 135. We want to prove that they are parallel. Prove parallelism between them. Okay, parallelism between these two lines, guys, means this is line 1 and this is line 2, for example. Means the two slopes will be equal. Okay, let's check. So slope for the line 1 will equal y2 minus y1, which is equal 6 minus 3, so it will equal 3 over negative 1 minus minus 2, so means negative 3. Okay, so it will equal negative 1. Okay, so the slope in this case equal negative 1. Okay. The second line slope equals, we said that we can get it using the points or we can get it using the angle. Okay, so tan theta here is 135 degrees. So tan theta, tan 135, actually, if you will check it on the calculator right now, it will equal negative 1. So simply, guys, the slope for the first line equals the slope for the second line. So this means the line 1 and line 2 are parallel. Okay, guys, that's the question finished. Okay, great. Let's solve one more example related to this. If a negative 1 and 2, a is negative 1 and 2, and b is 2 and 3, b is 2 and 3, and c negative 4 and 1, negative 4 and 1, and d x and 2, x and 2. Okay. Are 4 points in a Cartesian coordinates plane AB parallel to CD. Okay. Find the value of x. Okay, how to solve this question? Actually, it's very easy. Now, AB and CD are parallel. So this means if this 2 points on the first line, line 1, for example, no need to write line 1, it's AB. Okay, so AB, and this one is CD. So this means they are parallel. So the slope for AB equal to the slope for CD, simply. Okay, now get the slope of AB will equal y2 minus y1. Where is y2 and y1 and this data? 3 minus 2 means 1 over 2 minus negative 1, which is 2 minus negative 1, which is equal 2 plus 1, so 3. So this is the slope for the first one. Okay. Slope for CD will equal now y2 minus y1. It will be 2 minus 1, which is 1, over x minus negative 4, which is x plus 4. It's a given that, guys, the two lines are parallel here. So this means that the two slopes are equal. So simply 1 over 3 will equal 1 over x plus 4. So now cross multiply. Okay, so x plus 4 times 1, x plus 4 times 1, which is equal, of course, x plus 4 will equal 3 times 1, which is equal 3. So simply, guys, x will equal, I'm going to shift this 4 to the other side with negative, or I mean different sign. Now it's a positive, so the different sign means negative. So 3 minus 4, so x will equal negative 1. Okay, this question is clear, guys? Sorry.
Yes, Mister.
Okay, great. Then the next one. In the Cartesian coordinates plane, prove that the points A now, which is negative 1 and 6, and B, 3 and negative 4, and C, 2 and negative 1.5, are collinear. Okay, we studied that before, guys, actually. Collinear, okay? It was on the first lesson related to the distance. A, B, C collinear, so this means AB plus BC equals AC, okay? But this time it's related to the slope, okay? AB and BC on the same straight line or collinear means slope of AB equals the slope of BC, okay? Like if this is the straight line, if this one is AB, okay? To prove that A, B, and C are collinear on the same straight line means the slope for AB equal the slope for BC, of course, because they are lies on the same straight line. Okay, so let's solve this one. It's very easy, actually. First, I have to get the slope for AB. So slope for AB will equal y2 minus y1, so negative 4 minus 6, which is equal negative 10, over 3 minus negative 1, which is equal 4. So negative 10 over 4, which is equal negative 5 over 2. Okay. Then get the slope for BC. Slope for BC, it will equal negative 1.5 minus negative 4. Okay, so it will equal 2.5 over 2 minus 3, which is negative 1. Negative 1. So it will equal negative 2.5. Okay. Actually, the two slopes are equal. This one is negative 5 over 2, which is equal negative 2.5 also. Okay, guys? Okay, are we clear?
Yes.
Yes, Mister.
Okay, great. So guys, to prove that the 3 points are collinear, okay, we have to prove that the slope of the two straight lines, I mean the two line segments AB and BC are equal. So in this case, the 3 points lies on the same straight line. Okay? The next one, the straight line passing through the 2 points 1 and 5, straight line L1 passing through 1 and 5, and negative 2 and negative 1, negative 2 and negative 1. Okay. Is parallel to the straight line 2, okay, that passes through the 2 points 0 and negative 1 and 5 and 9 and 5 and 9. Okay, the question now, prove that, okay, the line 1, okay, is parallel to line 2. Okay, so it's very easy. I will get the slope for line 1 and the slope for line 2. So if the two slopes are equal, so this means the two lines, line 1 is parallel to line 2, simply. Okay, so slope 1, y2 minus y1, negative 1 minus 5, so negative 6, over negative 2 minus 1, negative 3. So the slope here equal to The next one, 9 minus -1. So 9 plus 1, which is equal 10 over 5 minus 0, which is 5, so equal 2. So slope for line 1 equals slope for line 2. So therefore, line 1 is parallel to line 2. Okay, one more example. If the straight line AB parallel to x-axis, okay, where A equals 5 and -4, and B -2 and y. Okay, find y. Okay, I will get the slope for AB first. Slope will equal for AB y minus -4, so y plus 4 over -2, which is x2 minus x1, -2 minus 5, so -7. Okay, now guys, AB is parallel to x-axis. Actually, this means the slope will equal 0. Okay, so this means y plus 4 over -7 equals 0. So cross multiply y plus 4 times 1 will equal 0. So this means y will equal -3. Just I'm shifting the number with different sign to the other side. So now it will equal -4. Okay, guys, is it clear?
Yes.
Yes.
Okay, great. The next point in this lesson, guys, actually it's about the relation between the slopes of the two perpendicular, okay, straight lines or orthogonal. Okay, two perpendicular straight lines, guys, like this. Okay, if there is one straight line like this one, okay, and another one is perpendicular to this one, so the angle, and this one is xy axis, for example, xy axis. Okay, this is line 1 and line 2. Okay, so if line 1 is perpendicular to line 2, so this means, guys, the multiplication of the two slopes, I mean slope for line 1 times slope of line 2, will equal -1. Okay, so the product of the two slopes of the two perpendicular lines equals -1. Are we clear about this one?
Yes.
Okay, so the converse of this one, guys, we said if they are perpendicular, so the product of the slopes will equal -1. Okay, the converse, if the product of the two slopes, S1 times S2, equals -1. So this means they are perpendicular. Okay?
Okay.
Okay, great. Let's solve one question. Prove that the straight line L1, which passes through the 2 points -1 and 4 and 3 and 7, is perpendicular to the straight line line 2, okay, which passes through the 2 points 1 and 1 and 4 and -3. Okay, so now it's very easy. I will get the slope for the line 1 and the slope for the line 2. Then I will check the product of these two slopes. It will equal -1 or not. Okay, so the slope 1, y2 minus y1, 7 minus 4, 3 over 3 minus -1. So 3 plus 1 means 4. Okay, the other one, line 2, negative 3 minus 1. So negative 4 over 4 minus 1, so 3. Okay, now the slope 1 times slope 2, it will equal 3 over 4 times a negative 4 over 3, which will equal negative 12 over 12, so negative 1. Okay, so this means line 1 perpendicular to line 2. Okay, guys, is it clear?
Yes.
Okay, great. One more question. In the Cartesian coordinates plane, if the point A, 1 and 7, A, 1 and 7, and the point B, 2 and 4, and point C, 5 and Y, actually represent the vertices of a right-angled triangle at B. Okay, that's great. So right-angled triangle at B, like this one. Okay, then find the value of Y. Find Y. Okay, right-angled triangle at B. So this means AB perpendicular to BC. So now I will get the slope for AB and the slope, okay, for BC. Okay, so first slope for AB will equal 4 minus 7, negative 3 over 2 minus 1 means 1, so it will equal negative 3. Then the slope for BC, it will equal y minus 4, so y minus 4 over 5 minus 2, so this means 5 minus 2 means 3. Okay, actually they are perpendicular, so this means SAB times slope for BC equals negative 1. So simply, if I will multiply the two slopes, I will clear this part on the board so that we can continue. So this means a negative 3 times y minus 4 over 3 equals a negative 1. So simply now I can simplify this 3 with negative 3, so the remaining will be negative 1 here. Negative 1 multiplied by this bracket, which is y minus 4. So negative y plus 4 will equal negative 1. So simply negative y will equal, shift this one, 4 to the other side. It will be negative because it's now positive, so negative 5. So y will equal 5. I will multiply the two sides by negative 1. So now y will equal 5. Okay, are we clear till now?
Yes.
Okay, great. So
Yes.
guys, in case if there are two lines are perpendicular, line 1 perpendicular by over line 2, okay? So the slope of the line 1, okay, which is S1 and S2. So simply guys, okay, slope 1 times slope 2 will equal negative 1. Okay, so this means slope 1 equals negative 1 over slope 2? Yes, of course. So it will equal negative 1 over slope 2. And slope 2 will equal negative 1 over slope 1? Yes. Okay. So simply, this means, okay, it's negative value of the multiplicative inverse, right? So multiplicative inverse and additive inverse on the same time. So if the slope S1 equals 2 over 3, so simply guys, S2 multiplicative and the additive. So 3 over 2, the multiplicative and the additive will be negative like this. It's a very easy way. Okay? Now this one is clear. I get both. Not to write down it will equal negative 1 over 2 over 2 over 3 and all this 2 over 3. This is easier. Okay, so multiplicative inverse and additive inverse. 2 over 3 multiplicative, so 3 over 2. Additive means negative. That's it. Okay, just 1 second, guys, please. Next question, if there is two lines like this one is xy plane, x and y, okay, and this one is x dash, and this one is y dash. Okay, if there are two perpendicular lines like this, one line here and the other line like this, if they are perpendicular, actually this one is line 1 and this one is line 2. Okay, and there are some points are given. Okay, this point is A, which is equal 0 and K, and this point is D, which is 4 and 0, 4 and 0, and one more point here, which is C, 0 and 1, and this point, okay, is B, which is negative 1 and 0. Okay, so the question here, if line 1 perpendicular to line 2, find the value of K. Find K. Okay, so simply, guys, the steps of the solution, I'm going to get the slope for the line 1 and the slope for line 2. Okay, then get the product of the two slopes and make them equal to negative 1. Okay, so first slope for line 1 will equal, okay, where is line 1? Actually, this one. Okay, I mean this one. So there are two given points here, C and B. They are lies on this straight line, which is line 1. So now, guys, the slope for line 1, it will equal 1 minus 0. So 1 over 0 minus negative 1, which is 0 plus 1, which is equal 1. So the slope will equal 1. Okay, then the slope for line 2. Where is line 2? Actually, this one. Where is the points? Actually, there is one point A and one point D. Okay, so it will equal 0 minus K. So 0 minus K over 4 minus 0. So 4 minus 0, which is equal negative K over 4. Okay, so now, guys, slope 1 times slope 2 will equal negative 1 because they are perpendicular. So slope 1 is 1, slope 2 is negative K over 4. So negative K over 4 times 1, okay, the multiplication or the product of the two slopes will equal negative 1. Okay, so let me change this color and write it here on the top and this part. So negative K over 4 times 1 will equal negative 1. So simply negative K over 4 will equal negative 1. Just a cross multiplication. So negative K will equal negative 4. So this means K will equal 4. Okay, is it clear?
Yes.
Okay, great. One more question. prove that the straight line which passes through the 2 points 7 and -1, 7 and -1, and 5 and -3, 5 and -3, is perpendicular to the straight line which makes with the positive direction of x-axis angle of measurement 135. So this is line 1, and line 2, there is one angle on the positive direction, which is theta, of course, equals 135 degrees. Okay, first I will get the slope for the first line. It will equal -3 minus -1, which is -3 plus 1, so -2, over 5 minus 7, which is equal also -2. So the first slope will equal 1. Okay, second one, slope for the line 2 will equal 10 minus 1, 435. Okay, so 10 minus 1, 435, actually using the calculator, it will equal -1. So now, guys, slope 1 times slope 2 will equal 1 times -1, which is equal -1. So line 1 perpendicular to line 2. Sorry, guys. Now, is it clear?
Yes, it is.
Okay, great. The next points, guys, the next points. Actually, it's some points related to the problems on the quadrilateral. Okay? Okay. The first one, guys, to prove that a quadrilateral is a trapezium. Okay, trapezium like this. For example, there are two parallel, okay, sides. Only two parallel sides are in this one, so this one is a trapezium, okay? Or in other words, a trapezoid, okay? Or even like this. This one parallel to this one. So also this one is a trapezium. Okay, so in this case, guys, if we want to prove that the quadrilateral is a trapezium, so two opposite sides are parallel, okay? And two opposite sides are parallel. I mean, if this one, so two opposite sides are parallel, and the other two opposite sides not parallel, okay? So in this case, it's a trapezium, because if each two opposite sides are parallel like this, so this means it's a parallelogram. So we have to prove that two opposite sides are parallel and the other two are not parallel. Okay, so in this case, we can prove that it's a trapezium. Are we clear till now?
Yes.
Okay, great. Okay, to prove that the quadrilateral is a parallelogram, okay? Actually, there are too much cases or too much conditions, okay, that we can prove that this quadrilateral is a parallelogram, okay? Parallelogram like this, guys. So if we want to prove that this one is a parallelogram, so first one we have to prove, if it's ABCD, for example, so we have to prove that AB parallel to CD and BC parallel to AD. So each two opposite sides are parallel. This is number one. Number two, each two opposite sides are equal. AB equals CD, or BC and BC equals to AD. So this is the second case. Each two opposite sides are equal. So we can prove that it's a parallelogram in case if AD parallel to BC and AB parallel to CD, or if we can prove that AD equal to BC and AB equal to CD. Okay. Then there is one more case. How? Two opposite sides are parallel and equal, like this. If it's A, B, C, D, A, B, C, D. Two opposite sides are parallel, like AD parallel to BC and equal. So this is enough to prove that it's a parallelogram. So AD equal to BC and AD also parallel, parallel to BC. Okay, so this is the third case. The last one, guys, okay, it's the two diagonals bisects each others. Two diagonals, so I mean AC and BD bisects each others. Bisects each others means this one equal to this one and this one equal to this one. Okay, guys, are we clear till now?
Yes.
Okay, great. Actually, we studied most of these cases on the first lesson. Okay, so also to prove that the quadrilateral is a rectangle or rhombus or square, okay? Sorry, rectangle or rhombus or square. Actually, guys, we said that first we have to prove that it's a parallelogram. This is first step, okay? First, we have to prove that it's a parallelogram. This is the first step on each case. Okay, the first shape. If we want to prove that it's a rectangle, I told you there is one step is common between all of them. First, prove parallelogram. Okay? Just 1 second, I will write it. So the first step is to prove that the quadrilateral is a parallelogram. Then, in case of rectangle, okay, prove that two adjacent sides are perpendicular, like this, A, B, C, D. So prove that two adjacent sides are perpendicular, like AB perpendicular to BC, BC perpendicular to CD, DCD perpendicular to DA, any one of them. Or the two diagonals are equal on length. I mean AC equal to BD. Okay, so this is the step number 2. This is the step number 1. Okay, so first, prove that it's a parallelogram on all cases. Then the first step, prove that two adjacent sides are perpendicular and the two diagonals are equal. Okay, if I want to prove that it's a rhombus, the same. Okay, first one, two adjacent sides are equal. First, if it's A, B, C, D, so two adjacent sides are equal, like AB equal BC, or BC or BC equal CD, and so on. And then the next step, the two diagonals AC perpendicular BD. The two diagonals are perpendicular. Okay. Then the last one, which is the, I think this is the square. Yes. Square. Okay. In case of the square, how to prove that it's a square? Okay. Only, guys, we can prove that it's a square with one of the following, only one of the following conditions. Okay. First condition, if it's A, B, C, D. Two adjacent sides are equal. Okay, two adjacent sides are equal and perpendicular. Okay, two sides two adjacent sides are equal and perpendicular. Okay, the second case, two adjacent sides are perpendicular and its diagonals are perpendicular. So two adjacent sides perpendicular and AC perpendicular to BD. And the two diagonals are perpendicular. Okay. The third case, if the two diagonals are equal, AC equal BD and AC also perpendicular with BD. So the two diagonals are equal and perpendicular. Okay? Okay. The last case, if the two adjacent sides are equal and the two diagonals are equal. Okay? So two sides, number 4. There is no enough space. I will try 4. I will write it here. Two sides are equal, okay, and the diagonals D are also equals. Okay, guys, so in this case, we can prove that it's a square. Are we clear till now? So again, briefly, if I want to prove that the quadrilateral is a square or a rhombus or a rectangle. Okay, so first of all, I have to prove that this quadrilateral first is a parallelogram. Okay? On all cases, first step, I have to prove that it's a parallelogram. Then, if I want to prove that it's a square, okay? So, two adjacent sorry, two adjacent sides are perpendicular and the two diagonals are equal. Okay. To prove that it's a rhombus, okay, so that two adjacent sides are equal, okay, or the two diagonals are perpendicular. Okay, guys? So,
Okay.
sorry, again, I wrote and, but actually one of these cases only, or. Okay, and here also or. Oh, yes, exactly. So, for rhombus, okay, two adjacent sides are equal or the two diagonals are perpendicular. Okay, to prove that it's a square, there are 4 cases. Two adjacent sides are perpendicular and equal, or two adjacent sides are perpendicular and the diagonals are perpendicular, or the two diagonals are equal in length and perpendicular. And the last one, two adjacent sides are equal and the two diagonals also are equal. Okay, guys, are we clear till now?
Yes.
Okay, great.
Yes.
Okay, great. Then let's solve some examples related to this one. On a Cartesian coordinates plane, represent the points A. First, I want to represent A, which is 3 and -2, and B, -5 and 0, and C, which is 0 and -7, and then D, which is 8 and -9. Okay, then prove that the quadrilateral is a parallelogram. Okay, now guys, I have to represent these points. Okay, like this. This is X, and this one is Y, Y dash, and X dash. Okay, so on the coordinates of X, 3, -5, 0, 8. Okay, so till +8, I have to write 1, 2, 3, 4, 5, 6, 7, 8. Then on the negative side, -1, -2, -3, -4, -5, -6. Enough. y, okay, most of them on the negative direction. So 1, 2, 3, 4, enough. And here -1, -2, -3, -4, -5, -6, -7, -8, then -9. Okay, the first point is A is 3 and -2. 3 on the positive direction of X and -2 on the negative direction of Y. So 3 and -2 means it will be on this place. Okay, so this one is the point A. Okay. Then point B, -5 and 0. -5 on X, okay, on the left, and 0, so it lies on X-axis here. So this is B. Okay. Then C, 0 and -7. 0 on X and -7 on the direction of Y. Okay. So lies on the negative part here on Y. So this is actually the point C. Okay. The last point, which is D8 on positive direction of X and -9. So it will be here. 8 and -9. So it will be like this. So this is point D. Now connect between the points A, B, C, D. So A, B, then B, C, then C, D, then this one. Okay, so we want to prove that this one is a parallelogram. So first we represent the points, then prove that it's a parallelogram. Okay, so guys, how to prove this one is a parallelogram? First, I will get the slope, okay? The slope of AB and CD, okay? AB and CD, so that I can prove them. I can prove that it's a parallelogram so that AB will parallel CD according to the slope. So the product of the two slopes will equal -1. Okay, so this is the first step. So slope of AB will equal, let me change this color. Okay, what is A and B? Yes, this point and this point. Okay, so the slope here will equal 0 minus -2, which is equal 0 minus -2 means 0 plus 2, which is equal 2. Then -5 minus 3 means -8, which will equal 1/4. Of course, it's a negative. Okay, then the slope of CD, okay, which is the opposite to AB, slope of CD. It will equal, where is CD? Yes, this one, and this one is Y. So -9 minus -9 minus -7, which is -9 plus 7. So it will be -2 over 8 minus 0, which is equal to 8. So it will equal -4. Yes, exactly. -1/4. Okay. So now, guys, the slope of AB equals the slope of CD. I think I said that we will multiply them and get -1. No, I was mistaken. Okay. Actually, guys, to prove that they are parallel, so the slope is equal. The product will equal -1 in case of perpendicular. Yes. I was confused. Okay, so the slope of AB equal the slope of CD. So this means AB parallel to CD. Okay. Now, guys, I will get the slope of AD, okay, and the slope of BC, the other two sides. So slope of AD will equal, where is A and D? Different color, red color, A and D. -9 minus -2. So -9 plus 2, which is equal to -7 over 8 minus 3, so it will equal 5. So the slope for AD will equal negative 7 over 5. Again, the slope for this is AD, then the opposite side is BC. Okay, so the slope for BC will equal, where is BC? This one, negative 7 minus 0, so negative 7 over 0 minus negative 5, which is means 0 plus 5, so 5. So the slope of AD equals the slope of BC, right? So this means AD parallel to BC. Okay, guys? So each two opposite sides now are parallel. So this means that this one is a parallelogram. Okay? Now this one is clear?
Clear. Clear.
Any questions till now?
No, thank you.
Clear. Thank you.
Okay, so the next question. Prove that the points A and B and C and D are vertices of the rectangle ABCD. Okay, now write down the vertices. It's A, 2 and negative 2, and B, 8 and 4, and C, 5 and 7, and D, negative 1 and 1. We want to prove that this one is a rectangle, ABCD, like this, I mean, A, B, C, D. Okay. Now, guys, okay, if we want to prove that this one is a rectangle, we said that first we have to prove that it's a parallelogram, right? Okay, so first I will get the slope for AB and slope for CD and slope for AD and BC, okay? To prove that each two opposite sides are parallel. So slope for AB equals, then slope for CD equals. So this is two opposite sides. The slope for AB, where is AB? A and B, okay? So 4 minus 2 means 2 over 8 minus 2 means 6. So it will equal 1 over 3. Okay. The slope for CD, 1 minus 7, so negative 6 over negative 1 minus 5. Okay. So it will equal negative 1 minus 5, negative 6. I think there is one mistake here. So it will equal 1. Check the first one again. It's AB. 4 minus negative 2. AB. Ah, yes, okay. It will equal 4 plus 2, which is 6. 4 minus negative 2, so 6. And 8 minus 2, it will equal also 6. So this means it will equal 1. Okay. Then the next one. So simply, guys, the two slopes are equal. So AB parallel to CD. Then the next step, get the slope for the other two sides, AD and BC. So slope for AD equals and slope for BC equals. Okay. Slope for AD, this is point A, this is point D. So 1 minus negative 2, 1 minus negative 2 means 1 plus 2, which is equal to 3 over negative 1 minus 2, which is negative 3. So it will equal negative 1. Okay. And the slope for BC, BC, 7 minus 4 means 3 over 5 minus 8, negative 3. So it will equal negative 1. So the two slopes are equal. So this means AD parallel to BC. Now it's a parallelogram. Okay. Okay. The second step, we want to prove that, okay, this one is a rectangle. So to prove that it's a rectangle, okay, as we said before, guys, okay, we have to prove two adjacent sides are perpendiculars. Okay, two adjacent sides are perpendicular, or the two diagonals are equal. Okay, we don't care about diagonals now. It's easy to prove that, okay, two adjacent sides are perpendicular, so this means the multiplication or the product of the two slopes for these two adjacent sides will equal -1. Okay, so let's check AB and BC. Okay, so slope of AB times slope of BC, it will equal AB equal 1, this one, BC equal -1, so times -1, so it will equal -1. Okay, so the multiplication of the two slopes equal -1, so this means, okay, AB perpendicular to BC, so this means this one is rectangle. Okay, now the question was finished. It's clear, guys?
Yes.
Okay, great. Any questions till now before we start the next question?
Nothing.
No, thank you.
Okay, great. The next question, guys, on the Cartesian coordinates plane, represent the points, okay, A, which is -3 and -3, and B, which is 3 and 1, and C, 1 and 5, and D, which is -2 and 3. Okay, then prove that the quadrilateral ABCD is a trapezium. Okay, now XY plane. This one is X, this one is X dash, this one is Y dash, and this one is Y. Okay, on the X coordinates, -3, 3, 1, and -2. Okay, so 1, 2, 3, 4, -1, -2, -3, and then Y till 5 from positive. Okay, 1, 2, 3, 4, 5, and -1, -2, -3, -4. Okay, now start to represent the points. The first point, it's A, -3 and -3. -3 on X, so on the left, and -3 on Y, so it will be on the bottom left. Okay, here. Next point B, 3 and 1. 3 on the positive direction of X, so on the right, and 1 means on the top, so here. So this is point A. I mean this one, A, and this point is B. Okay, then C, 1 and 5. 1 and 5 on the top here. This is point C. Sorry. 1 and 5 here. So this is point C. Then the last point, -2, okay, and 3, so it will be here, -2 and 3 here. So this is D. Now, guys, draw your shape, connect between the points A and B, B and C, C and D, and D and A. So now, guys, we finished the representation. Now, the next step is to prove that this one is a trapezium. Okay. So to prove that this one is a trapezium, we said that we have to prove that, okay, two opposite sides are parallel and the other two are not parallel. Okay, so the first two opposite sides, CD, so I will get the slope of CD, and the slope, which one is opposite to this one? AB. Okay, and the check, and also I will get the slope of this one, CD and AB, so the other is BC and AD. Okay, so CD, what is that CD? This point and this point. 3 minus 5 means a -2. Over -2 minus 1 means a -3. So it will equal 2 over 3. So this is the slope for CD. Okay, next, the slope for AB, A and B. 1 minus -3. 1 minus -3 means 1 plus 3, which is equal 4 over 3 minus -3, which is equal 3 minus -3. So 3 plus 3, which will equal 6. Okay, so 4 over 6, which is equal, after simplification, it will equal divided by 2, means 2 over 3. So now, this slope equal to this one, yes, so CD parallel to AB. Okay, that's great. Then I check the second two points, which is the slope of BC and the slope of AD. Slope of BC, this is BC. 5 minus 1 means 4 over 1 minus 3 means a -2, so it will equal -2. Okay, so the slope for BC will equal -2. Then finally, the slope of AD, A on the top here and D. Okay, 3 minus -3, so it will equal 6 over -2 minus -3. So -2 plus 3, which is equal 1. So it will equal 6. Okay. So now, guys, the slope of BC not equal the slope of AD. Okay. So BC not parallel to AD. So simply, two opposite sides are parallel, two opposite sides are not parallel. So the quadrilateral, okay, which is ABCD, is a trapezium. Okay, guys, are we clear?
Yes, mister.
Yes.
Any questions till now?
No, thank you.
Okay, great. Actually, we finished the lesson 3, which it was about the slope. Okay, next session we are going to start the last lesson in this unit, which is about the equation of the straight line. Okay, which given its slope and the intercepted part of y-axis. Actually, also it's very easy. So, do you have any questions, guys, related to our lesson? Any
No, thank
questions?
you.
Okay, great.